we were looking at what happened this morning. What did we do this morning, Matt? What happened this morning? So what happened? You guys are like food comas. You're hammered. So I had some chemical, and I shined an invisible light on it, and then light came out. And what I was saying is the electrons got excited, and they got off a different light, so a visible light. So what we're going to do, we're going to take a metal, and then we're going to heat it up with fire, which is essentially energy. We're going to add all chemical reactions either give off energy or they absorb energy. So we're going to put energy into the metal, and then the metal is going to turn into it's called a metal ion. I use all these symbols, but a metal ion, and then it's going to give off light energy. And you'll see this. So, and we're going to use different metals, and different metals. When the metal ion loses its electrons, so there's some electrons that leave. And so symbolically in the class, like when the one we did, you remember that strip we burned and it burned really bright? That was that one demo. So we took magnesium and heated it up, and we created magnesium 2+. And this was the metal, and then we had the metal ion. And so we haven't learned there's all these rules, which metals use how many electrons. You don't have to worry about all that this week. We worry about that in Chem 22 during the regular semester. But just to notice the idea, when it releases these electrons, it releases energy. There's energy given off. So we're going to show this demo. What we have are metals dissolved, salts. We have metal ions. So this is a little different. We're going to excite an ion, and then when we heat it, it's going to give off light. You'll see this happen. Let's take. Well, I guess I'll get started. Actually, does anybody want to help with this? This one's not so dangerous. It's just a little fire. Right? Never mind. Okay, hold on. First. Sorry, set up. So there's two ways to do this. Is a short demo as well. I'm going to take the lights out. Make it dark in here. Is it okay? Can you guys see? Actually, it's fine. Does someone want to shut the door? We can maybe leave that one too dark. I'd be able to see what I'm doing. Is that too dark? Is it spooky dark, like Halloween dark? Light. Okay, so I'm just going to take its metal ions in a solution, and I put them into the flame. Okay, that one's kind of boring. Hold on. For some reason, the cotton swabs are not absorbing. Let me open that door again.
Oh.
Not just the word. There you go. I don't know what that one is. Let's try this one. Okay. So this is I believe this is a copper ion. Okay, it's definitely wet. It should do its trick. There we go.
Ooh.
So we see the metal ions when they get excited, put the energy into them. They're releasing the heat, the light that you see. So in different metals, the electrons are in different energy positions. So because of that, because of the way the electrons get excited and decay back down, they'll produce different wavelengths of light. This one is sodium. And let's see, sodium. Sodium doesn't see the golden flame. It's different from the fire a little bit. It's golden by itself. So that's sodium. That's the golden color. That's pretty good. Okay, this is This is borax, and so what you're doing is you're exciting the boron. And boron's kind of in a metal, non-metal area, but in this case, it's going to begin like the metal. Let's see what more. Oh, nice green. There we go. Let's try and get that one. It's supposed to. This one's supposed to give you a nice green. It's just a little bit green, so it's not big enough as well. Let's try a different one. You know, spray bottles. You guys want to see the spray bottles? They said, this is kind of new for me. The Q-tip was a suggestion to try it this way. This is strontium. It's an ion compound, strontium nitrate. That doesn't matter, but the metal is strontium. There's several. There's almost how many metals are there, Matt? There's a lot of metals on the way. It's kind of reddish. Maybe we should do let's do the spray. I'll do the spray. The spray is more impressive, I think. Let's see if I can read which one's which. Okay, this is copper chloride. Let's do that. Okay. I guess the spray flame works a little better. I guess like the spray flame. And let's do the sodium. The sodium you couldn't really tell because that golden color didn't really stand out very well. That's sodium chloride, just table salt dissolved in the right solvent. This is a different state of copper. This is copper sulfate. Let's see if it's going to be a little also green. Okay. That's kind of neat. You guys, does the assistant want to help me with any of these? No? You guys are ready? We have fire insurance.
Mr. Campton?
Yes.
Shannon wants to.
Who?
Shannon.
You want to do it?
Go.
Come down.
Just jump. Don't think.
So this is strontium.
Take cover.
Okay. So here we go. Lithium chloride. You just spray it into the fire. Not that far. It's fine. Oh, that's a nice one. Wow.
It's actually not.
Guys, a while back, you used to be able to buy at Christmas time Presto logs that would burn in your fireplace and give off colors.
It was produce a lot of energy.
So they do red and green by putting these salts in with the Presto log, and as your fire goes pop and crackling, you get all these colored flames.
Yeah, I remember that too. Like you could take, the colored magazines. I shouldn't do this, but I burned the colored magazines in the fire, and you get these green flames because there's some of these metals in to make the photographic pictures. This is potassium chloride. So it's kind of like a pinky color, huh? Give it a couple squirts. There you go. It's kind of a pinky color. All right. It smells gross. Okay. Interesting. Let's do calcium.
What happens if we spray together?
That's what. So calcium's kind of orange. That's kind of neat. And then let's do one more sodium. I think we've gone through the whole pattern here. Yeah, that's orange. So that's what the guys did last time. They went crazy and they tried to. Once I started doing the demo, they're like, "Oh, we got to do it." They started doing flames together and trying to make like that, the skunky one. Okay, go ahead. So, pink. Lots of colors. Okay. Well, I guess it depends on which one delivered the most chemical. So that's the basic demo for the afternoon. Do you guys have any questions about it, or?
Are the solvents all different?
No, the solvent's all the same. The solvent's methanol. Did you guys like that one? Yeah. So methanol is kind of related to, ethanol. And ethanol is that's your drinking alcohol. So if you got really, if you wanted to try and do this at home, you could probably, I think ethanol would do it. I'm not
We
sure.
use IPA. We use IPA.
So you could probably use rubbing alcohol. I don't know. So rubbing alcohol, if you want to do this at home, and then you would mix, you try to dissolve, they won't dissolve in your salt. So rubbing alcohol plus table salt. That's one you can get pretty easily. That's a gold thing. It's not as impressive. The borax, and you guys heard of 2014 borax? You can go buy that. So borax will give you a nice green flame. The other ones might be harder to find. I don't know where you find lithium chloride or lithium copper salt and so on. Sometimes you can just burn a piece of metal, and if you have a fire that's hot enough like this one, you can do that. And after this all right, I guess that's our demo. If you guys have any questions, we're gonna do the labs. Do you have anything, Matt?
Do the labs.